With the like starting point into zero, could you like show what the table would look like? Because I think I understand it, but I like
Right.
lost.
So show what the table would look like in what respect?
Like when you were walking back in.
Okay,
like,
all right.
Yeah.
Oh, now I remember. Sorry, don't have to wake you in the middle of the night. We're looking at acceleration several different ways. We've got this way of looking at it right here with the speeding up, slowing down. We have this way of looking at it right here, which is the direction of the total force, whether someone's pushing, the net force is pushing one way or the other. Then we have the more mathematical look at it, which is basically what I have right here with the numbers. They all work hand in hand. So for a particular problem, it's not a question of which way should I be looking at it that's going to be right. They're all right. Just whichever way your mind is working at that moment, go with it. All right, so what this would look like is I'm not going to hit 15 meters per second. That's over 30 miles per hour. But
Let's not.
just,
But you're faster than
just
us.
imagine.
Yeah.
So that's what's happening.
Okay.
Cool. And so the acceleration is the same throughout that?
Yes,
Okay.
It's like.
perhaps not in my actual physical demonstration.
Right. Okay.
But yes, the acceleration is the same based upon this.
Okay. Even when you're going the other direction, because that's where I get confused. Like when you're stopping there, like I thought the acceleration would have to change to make you go the other way.
It's like a stronger force though. Like if he's going and then you've got acceleration pushing on you and it's stronger than you are, then it'll like turn you. You'll both go the same direction. That's why it's like whenever you're speeding up, it's the same sign because the acceleration's like also helping you.
Force.
Okay.
You should be using the word force there.
Yeah.
Okay.
Is that,
That helped, yeah.
okay? Then I'll try not to confuse it.
Okay.
We'll do a couple more plus minus zeros, and then we'll set up for what was a test level problem, and then I thought, this is too easy. We're gonna make it more complicated, but we'll get there. All right. Velocity,
Positive.
position,
Negative.
Positive. Positive.
now my displacement,
Positive.
Positive.
it's going too fast. Velocity,
Negative.
Positive.
Positive. Wait,
Where's
yeah,
the
positive.
I'm going in the positive
Okay,
direction.
sorry.
So velocity is positive, acceleration,
Positive.
Positive.
Zero.
Zero? No?
I was thinking of zero, I know I'm not can't block perfectly, but the intent was zero. The moment that I stopped, what was my acceleration?
Positive.
Positive.
Okay, the moment that I stopped, what was my acceleration?
Negative. Negative.
My velocity,
Negative.
position,
Negative.
displacement.
Negative.
Negative.
Now for the ball problem. I'm gonna set it up. Part of this exercise is one, applying this to a different situation. And part of it is learning notation. I know, it's exciting, learning notation. We're just gonna borrow from math notation, so it's not, so bring down your expectations.
That's good.
The issue, I feel like I'm drawing my cousin Andy, who, actually, cousin Andy would be like that, but he was born with an arm basically to here. And there's this family story of, would suck on the end, basically it was a nub, and they had these tiny little points that would have been his fingers, but it was a birth defect. But he was sucking on the end of it, and this older woman came up and was just trying to be cute with him and said, "Oh, if you're not careful, you might swallow your hand." At which point he pops out the knob and his hand is missing. His parents didn't explain. All right, so this person throws the ball up into the air and down.
Oh, boy.
Something like that. The problem begins just after ball leaves hand. Problem ends just before ball touches ground. So I do not care what happens before the problem begins or after the problem ends. I'm going to label 4 moments in time. A, B, C, and D. So A, time just after ball leaves hand. B, time ball is at peak. C, time ball is at same point as at time A, but all the way down. And D, time just before the ball touches the ground. To establish 2 other conventions, we will make up positive just so that we're all doing the same problem. And I'm going to make the ground equals 0. So any questions on what the setup is before I actually talk about what I want you to do? So what I would like you to do is to go through the times when the position is positive, negative 0, when the displacement is positive, negative 0, velocity, positive, negative 0, and I'm sure you can guess acceleration.
Positive,
Positive,
negative
negative
0.
In whichever order you wish. Now notation, now some students, they get to this and they just put in A, B, C, or D, but recognize there is time in between A and B, and there's time between B and C, and time between C and D. So if I write the notation as like this, A to B, the hard bracket means I'm including that letter, that time, and the parenthesis means that I'm not including that. So this would be from time A to B, including A, not including B. If something happens at just time A, then I would just write A. I don't have to put brackets around it, but some people do. If you put A with parentheses around it, then that means,
It's not including A.
yeah, which would be strange.
Yeah. Everything but A.
But nothing else was listed, so it's nothing
Yeah.
and also not A.
Yeah.
And then if it happens from A to B, including A and B, you put brackets around both, so this is A to B, including both, including A and B. And then parenthesis, A comma B, A to B, not including A or B. Ian?
Are we referring to A as our starting point?
A is the time just ball leave hand, wow, just after. And the problem begins just after the ball leaves the hand, so I think it's a reasonable conclusion.
After ball. I was just reading what you had written. Problem begins just after ball hand.
Just after
We get
ball.
what you mean.
I appreciate that. Right, a little bit of, occasionally the monk side of me kicks in and.
That's what happens when you operate at a higher plane.
Yeah, let's go with that. My wife doesn't buy it for some reason. I didn't hear a thing that you just said, because I was just operating at a higher plane. Then reality, after 20 years of marriage, I don't have to listen to her anymore. The other thing is that if something happens from A to C, so from A to C, let's exclude A, include C. I don't have to write B. B is between A and C. So this would just be excluding A, so I put a parenthesis, and then C with bracket. So it's implied that B is part of that. All right, so I'd like you to spend some time, say 10 minutes, trying to fill out the chart there. And feel free to work with somebody. This is not a quiz. This is supposed to be a learning experience.
And we're defining, since you said the ground is 0, that's our origin, right?
Yes.
Okay. I'm in trouble already, deep position, because I can't tell if that's positions from origin, right? It's not from the start point, it's placed between the start point. Yeah. But we could make our origin and starting point. No, because ground is 0. Yeah, that's right. So that's, I think I just answered my own question. Forget it.
I said that we
No reason. Yeah.
So it's the. It's about.
You know, because displacement is not the starting point. Varies, no, no position. D is only touches the ground.
Just before that.
Technically.
But I don't know if that's right.
No. It's above ground.
Is this taking place purely vertically? Do you throw it up and then it comes back down in the
Yeah.
same way?
Yeah, assume that it's a one-dimensional problem.
Brackets on either side.
I would do parentheses.
So, A is the top, and just leaves the hand. So,
I do think you clarified this, but just to, for my brackets,
Yeah.
and maybe for other people's brackets.
That's how
You
said it.
decided that A, after which is left of A is our starting point, not the starting point being the ball in the hand. The starting point is after the left the column of this.
yeah,
Yes.
why would we exclude A? Because A is already present.
Yeah. Yeah, I guess you're right.
start of day, his effort ball.
So,
It's season line up with that.
so this plane, this blizzard means that that's the only one where the one was right.
Start point.
It started. So then, like, why would it be from A to B?
Because you're still comes into the C. A is line up with C, and A is line up with the ball. It's the same. Yeah.
So not all sections have to be one.
No. You're not always gonna have the zeros. So. The displacement. That's got a parenthesis there, which means no, A is right after the ball leaves the hand. So, velocity deals with and it should be, on a test, I was saying about displacement, the displacement. Here you got, yeah, see, it's right at the bracket there, where the ball leaves the hand, two spots, for A. Yeah, so it's possible to find that, yeah, and then same with C. So it's, yeah. Yeah. Position cares about that.
Oh,
Starting
yeah.
point, or doesn't have, because you can make starting point, right?
Yeah, how could have negative, position, or position of displacement if the ground is zero? Is that something?
Yeah, because it gets to nothing point and then it goes back down.
That's the point. You've left off everything between B and D, but that's a parenthesis.
Oh, yes, yeah.
B is
So-
zero.
Yeah.
C would be full.
Right.
So
That's what I
it's C.
What, if it's positive, right?
So B and D are equal to zero.
Oh, from the ground, okay, never mind.
Because when it reaches the ground, it's zero.
So it would just be everything in between, you know, beginning and the ground, if it's above zero, if the ground is zero, is what I'm saying.
Yeah, and also, D is just before it touches the ground,
Mhm.
and the problem ends just before it touches the ground.
It's easy to
The
see.
same goes, it comes straight back down into the line.
I'm just confused about what you guys do with the.
Yeah.
For,
You said positive or C?
yeah, well, I put it in the parentheses, so I
Can I help
put
you
it against the.
to turn this, like the way that he was like walking back and forth?
So-
This is like your,
Acceleration is positive.
your
when
A is your
velocity
starting
is
point,
positive.
and then this is like your
Acceleration is
force.
negative when,
Does that help you a little bit?
no, when
That's
velocity
how
is
I
negative,
looked at
it's
it, cause
positive.
this way I was like, this.
Oh, it is positive. Are you talking about?
Let's see, so
Yeah.
for
Because-
velocity, I said, I included A,
Because the,
because it says like, it begins right after the ball leaves the sand.
It's already moving on.
B
Right, so it has
opposite one is
positive
negative
velocity
velocity.
from A to B.
So it
Now I'm
literally
hitting D, right, and then at B it's zero, because it's like still. And then not including B,
So it would also.
including D, that's your negative velocity. And then acceleration includes negative the entire time.
It's the V, like acceleration. The opposite. Once you're throwing the ball out, it's like
You got it?
slowing down.
Okay, cool. It can be like you guys really have.
You're saying that the ball is stopped at those 2 points?
No, because the acceleration started when you grew up. So you
He said to make a list.
made it positive acceleration.
I'll have to use like the
Then
Excel web.
gravity acted on it and it becomes, it's still positive because it's a negative velocity.
Like somebody else. It's good.
Which,
There's a lot
Yeah. No, he said when the velocity is positive, acceleration is positive. It's only when velocity is negative that acceleration is negative. Yeah.
That's the there. Well, I think it just kind of depends. Like, I don't think that's true. Yeah. Depends on where you have. You're speeding up, then velocity. You're slowing down.
All right, let's try to do a right balance between people having good conversations and people twiddling thumbs. So, I'm gonna call it there. Let's take a look at it as a group. I apologize if you're in the middle of a really great conversation concerning this. All right, so position cares about where it is relative to 0, and where is it relative to 0? The entire time. The ball never touches the ground as far as this problem is concerned.
Right.
So, the entire time, A to B. Now, here's a slightly different way of expressing the same